The dental operatory presents a specific set of respiratory hazards. Here, the primary threat is completely invisible to the naked eye. When a high-speed dental drill strikes a wet tooth, it generates a microspray that expands outward violently. Routine tools, from high-speed handpieces to ultrasonic scalers, produce a suspended microaerosol cloud that lingers in the room long after the procedure. This cloud carries a heavy biological load, specifically aerosolized viruses and bacteria drawn directly from the patient's oral cavity. It also contains vaporized chemical components, volatile organic compounds, or VOCs, such as glutaraldehyde and methacrylates, enter the air during routine treatment. These specific VOCs create the distinct dental smell that negatively impacts patient perception and increases anxiety. Because these particles are microscopic, they remain suspended in the air. This mixture of biologicals and chemicals hangs directly in the breathing zone of both the practitioner and the patient for hours. Traditional infection control protocols focus on sanitizing surfaces after the appointment. This leaves the primary airborne transmission route unmitigated during the actual clinical treatment. The standard response to these airborne threats is relying on high-grade HEPA filters and increased HVAC air exchange rates. Passive filtration has an inherent mechanical limitation. It is a sit-and-wait technology. A corner HEPA filter can successfully pull air near its intake, but it leaves a stagnant danger zone directly over the dental chair. This creates a proximity paradox. The distance between the contamination source and the clinician's respiratory tract is often just 18 inches. An aerosol cloud can expand and envelop the dentist long before ambient air currents can draw it toward the HVAC intake. The fluid dynamics fail at the source. Passive systems cannot physically cycle the room's air fast enough to remove the aerosol before the clinician inhales it. Upgrading to a higher-rated HEPA filter does not change this, as it does not alter the base physics of physical distance and air transit time. To protect the breathing zone, clinics must move past the passive capture model. A reliable defense requires a system that actively neutralizes threats at the point of origin. Neutralizing aerosols before they travel requires a shift from passive filtration to continuous active spatial neutralization. This active environmental control was originally engineered for the Space Shuttle Columbia to eliminate VOC buildup in enclosed aerospace environments. The mechanism adapting this technology for clinical use is advanced photohydrolysis. Inside the unit, a proprietary matrix converts ambient humidity and oxygen into highly energetic, radiating particles. These neutralizing molecules are specific hydroxyls and superoxides. Instead of waiting for air to reach a filter, these molecules are projected outward, flooding the entire volume of the room to create a continuous active shield. When these molecules collide with aerosolized pathogens, they rapidly attach to, pierce, and collapse the outer lipid shell of the virus particle. Laboratory data from the University of Texas Medical Branch shows this mechanism achieves a 99.9% reduction of airborne viral particles, including SARS-CoV-2, in under 1 minute. Advanced photohydrolysis effectively uses the air as a delivery system for these molecules, neutralizing the toxic cloud the moment it is generated by the dental drill. These laboratory results have been validated by peer-reviewed clinical outcomes in high-risk healthcare settings. Studies published in the American Journal of Infection Control tracked the technology's performance in active intensive care units over 12 to 21 months. These bar charts illustrate the findings from the Louisiana and Kentucky sites, a 70% drop in total healthcare-associated infections post-activation. Simultaneously, MRSA and fungal colonies on floors and surfaces were reduced by over 99%. By successfully breaking the chain of infection in an intensive care unit, the technology provides a significant margin of safety for the daily risks of a dental practice. If this technology actively destroys viral and bacterial cells, is it safe for humans to breathe continuously? A comprehensive safety study published in the journal PLOS ONE used a mammalian model to answer this question. Subjects underwent continuous 90-day exposure to therapeutic levels of advanced photohydrolysis. Histological examination of the respiratory tissues showed 0 adverse effects, 0 inflammation, and 0 tissue damage. This combination of lethal efficacy against pathogens and verified safety for mammalian tissue allows clinics to operate the system 24 hours a day without risk to staff or patients. Integrating this technology into a modern dental practice is a direct logistical process. The hardware is scalable. Whole building coverage is achieved through the Induct Guardian series. The Induct unit installs directly into the clinic's existing HVAC ductwork, requiring no major architectural changes. Portable solutions, like the Pure and Clean units, provide localized shields for high-risk operatories or busy waiting rooms. The system operates on low amperage and requires only simple annual maintenance, avoiding the energy strain associated with high MERV filters. This approach enhances the building's existing airflow infrastructure, rather than creating additional resistance. Sani Active functions as a dedicated environmental wellness partner, designing bespoke air quality strategies for forward-thinking dental practices. Their experts engineer air quality strategies tailored specifically to the unique footprint and clinical workflow of each practice. Practices that maintain these strict protection standards are awarded Sani Active Verified status. When patients scan the QR code on the clinic plaque, they are directed to a digital portal that validates the facility's active environmental protection. This provides the practice owner with a verifiable elimination of odors, fewer staff sick days, and a foundation of patient trust. In the face of modern aerosol threats, waiting for the air to cycle through a filter is no longer sufficient. To protect the breathing zone, you must actively purify it. Contact Sani Active to secure your verified status